Hey scholars, this is the video I promised about needing because of probably the police will be coming sixth period in order to do a lockdown drill. But at the same time, oops, of course that would be in the way. I just really appreciate you guys watching this, doing what it's asked, and make sure we get the final details because we do need to be ready to take this stuff on the test on Friday. All right, so we're talking about finding the inverses graphically. And one thing we want you to know that if you have two functions that are inverses of each other, you can know if they're inverses because if you look at their graphs, the points will exchange. So for instance, if you're xy in let's say f of x, in g of x, the inverse, or let's say the inverse function, your ordered pairs that work are going to be the y and x. They change spots. An example of that would be if I had two tables and I had x, f of x, and I had over here x, the inverse function of that. Let's say I had 1, 2 here, the inverse would be 2, 1. Or if I had something like 3, 5, this would be 5, 3. They literally flip-flop spots on a table. Now, the part that I actually like, because it's easier to do, is when we graphically think of things, is to actually picture the graphs, because we're good at graphing functions at this point, and realizing it's a reflection over the line y equals x. Look, it's our linear parent function. Now, it can be helpful if you're struggling to do this to create like an XY chart, like I showed you the tables up above, in order to figure out what are, but you can also use your graphing calculator to do this. So that's really what we're going to want you to do, is practice with your graphing calculator in order to do this. So here's what I need for you guys to do. I need you to use your TI-84 plus CE graphing calculators. And I'm going to go get mine real quick. It should be showing up here at the, oh, I got to take it off tablet mode. So sorry, my friends. All right, you got to see all my personal stuff there. Isn't that exciting for you? Okay, so here's my graphing calculator. And I need you to go into your y equals functions. All right, so go into y equals. I need you, and I'm going to clear this, so I'm going to show you how to do this quicker, to do the following. So the first equation was x cubed. So remember, all you have to do is hit your, I call it variable button, and get your x. But then you could do caret 3, but if you go to the math key and you go to number 3, it gives you the cube. And if I need to, the second equation is the cubic root of x, go math, go to number 4, and it will give you the cubic root, and I'd put your function x there. And then I want to show that it reflects, because if it's true, if I draw this line in, you could see like it's perfectly flipped over that line, y equals x. So I'm going to graph that as well. So x cubed is going to be in blue, y2, which is cubic root of x, and then y cubed is x. So I'm going to go zoom, go to number 4. This is what your graphs should look like. So the blue graph is x cubed, the red graph was the cubic root of x, and here's my question. The line y equal x totally got drawn in here, correct? You guys see where I'm looking here? Okay, awesome. And the cool thing is you can tell it's perfectly reflected over that. It almost kind of looks like a bug or something like that that is formed. That lets me know that those two graphs are inverses of each other. So it's a quick graphical way to do this. So here's what we're going to do. On your homework, there are several problems. I think it's 19 through 23 that says, hey, can you find the inverse, and then check to see if graphically if you are correct. Use your graphing calculator, and then please draw for me the rough graph of what you see. So like what you just saw on the calculator screen where you have your two functions. And this is not a good example of that. Yeah, my blue one's really bad here. All right, retry. There's my cubic. I'm going to do its inverse. Should look something like this. and there was your y equals x. You don't even have to do the y equals x if you don't want to. But I need to see something like that so I know what was visually on your graphing calculator screen. It just gives me a quick visual to agree with you or not. Now, here's the next question. It says, does the following graph have an inverse? If so, sketch it on the coordinate plane. Explain your reasoning. Well, how do I check first? That's right, the horizontal line test. So, does it have an inverse? Yes. It passes the horizontal line test. Awesomeness. Great. So what would its inverse look like? Well, first of all, here's the line it should be reflecting over. But remember, if you have this, and this would be like 0, I'm going to say 1 because I know this is an exponential equation. That's e to the x. I know its inverse, and let's do the inverse in baby blue here, is going to be the ordered pair 1, 0. So I'm going to go over here at 1, 0 because if they're graphical inverses, they're reciprocals of each other. Also think about this. This had a horizontal asymptote. So if it reflects over the y, notice there's your new asymptote. It's vertical. And you will get to the equation that looks something like this. And by the way, that's your natural log. But how did I know how to draw it that way? Just remember, if I have two inverses, remember, f of x and my function inverse, those ordered pairs are going to switch spots. So even when I think about horizontal vertical asymptotes, like how does that reflect over? That's what we're going to get. So it's just a quick, easy, graphical way of doing this. But remember, the key really was knowing, oops, did that the wrong way, knowing that the ordered pairs would switch spots. So like think over here, if I had like a -10, this would be really close to say to be positive 0.05. Well, that meant over here at 0.05, I'd be over here at -10. So it works very easily where you can see like the relationships growing with the two of them. Okay, so quick, easy visual, make sure you have the basic idea. But what if I want to do this graphically? We're going to use compositions, okay? So we're going to use Fogg and Goff. So we need to know that f of g of x and g of f of x will always equal 3. Always equal 3. Wow, that's a great moment. Always equal x. So if I take one of these in, so one composition, the other one has to do the same thing. So we're going to just practice what we learned in the last chapter, because if they're inverses of each other, it's the way that we can check without doing it graphically, we know it will work. All right, so let's do number 1, and let's do number 1. I'm going to just do it in green here. Okay, so I'm first going to go for number 1, f of g of x. So that means I'm plugging g over x of x plus 2 in for the x of my function f. So we're going to go this, f of 5 over x plus 2. Where does that go? Well, I've got the quantity 5 over x plus 2 minus 2 all over 5. So I'm going to simplify that, and the 2's in the numerator simplify out. And then I get 5 over x all over 5. I'm going to make that a reciprocal. And I get the following, 5 over x times 1/5. So 5 over 1 I made into a fraction, so then I use its reciprocal, because if you divide by a fraction, you multiply by its reciprocal, and I get 1 over x. Is that equal to x? No. So right away, I know they're not inverses. I don't even have to take the time, because even if it worked for g of f of x, it didn't work for f of g of x, so why bother with that? But then we're going to take the following ones. We got to check them out, okay? Make sure I've got our values. So here, we're going to verify it. Now, we're going to do this using Fogg and Goff, all right? So we're using our compositions. But with this, f of g of x, we know we're going to do the following. We're going to take the cubic root of x plus 1 all over 2 and plug it into my function of f. So remember, this is going to go into that value. So we get here 2 times, oops, let me put it in back, 2 times the quantity, the cubic root of x plus 1 all over 2 being cubed minus 1. So what do we get here? The cube of a cubic root means what comes underneath the cubic root comes out. So I get 2 times the quantity x plus 1 all over 2 minus 1. Well, the 2's simplify out, and I get left with x plus 1 minus 1, and I get x. So f of g of x is equal to x. Great, that's one step. Now I have to go the reverse way to check g of f of x. So this is how I'm verifying this algebraically. I will check when we're done graphically to make sure it makes sense. So what are we doing? We're plugging in whatever f of x is into g of x. So we get g of 2 times x cubed minus 1. So we're going to go the other way around. Let's see if I can go this way. Let's see if I can use this one. I'm going to take this one and I'm going to plug it into that x variable. So we're going to take the cubic root of, what do we got here? The 2x cubed minus 1. And we're going to go plus 1 all over 2. So we're going to simplify the numerator of that fraction. So we get 2x cubed all over 2, which is the cubic root of x cubed. And the cubic root of x cubed is what? X. So, my friends, these mean these two functions are inverses of each other. So let's have a little bit of fun and try this on our calculator. All right, so I'm going to go into my calculator. I'm going to go my y equals. I'm going to clear this sucker here. All right, I'm going to clear that one. All right, I'm going to do the first equation here. That's going to be 2x cubed. And we're going to go minus 1. And then our next one is going to be the cubic root. So we got to go math. And we're going to go number 4. And then I'm going to go alpha y equals so I can do fraction in it. And I'm just going to make it look exactly what the equation was before. And I got x plus 1 all over 2. And notice I kept my graph for y equals x. I'm going to go zoom 4 so I can graph it. My friends, if I asked you to graphically reinforce that they're inverses, this is what you would show me. You do a rough graph of that. And again, that's like equation problems 19 through 23. You have to algebraically show it to me, so you do your compositions. And then you're just going to run and do a quick graph of this. So this is what's really cool. If I asked you to verify this graphically, use your calculator and then just draw me real quickly, you know, the two, like one of it like this, and the other one, like, I don't know. That's not the best looking one I've ever done, but hey, something like this. And that they would reflect over each other. Does that make sense? You just need to basically show what's on the computer screen, which most of you do much better than what I just did. Does that make a plan? Hopefully that helps you finish this up. Thank you guys for your patience. Hopefully we're able to get all this done in class today, so you don't have to watch this.